Welcome to the December 2006 Jug. I'm Brian.
Hi, Brian.
Hi, Brian.
Dog,
I love you, dog.
I'm sorry, what?
He loves you, dog.
Inner joke. Move on.
Okay, is that a show? So a few things. The next steering committee meeting will be at Francis Tuttle on the 28th, which is a Thursday night, 6 o'clock. Christmas is like right before the time. The next Jug meeting will be on January 9th, which will star Barrett Newsom back there, and it will be on continuous integration or something thereabouts, I guess.
That's right.
Found out today that the guy who handles the sponsors for the Jug, Duncan McDonald, is going to be way too busy with his new job to continue doing it. So if anybody's interested in contacting sponsors and making sure everything's lined up, let me know or let one of the steering committee people know. I'm kind of looking for donations. I sent an email out because we ran out of plates and cups and stuff. And I had one response, and the guy wanted to come and preach or try and sell you insurance. So we told him no. So if you guys want to drop $1 in the little can back there, where we usually put our, where we put our coupons. No, not coupons. The tickets for the giveaways. I'd appreciate it. I should also bring it up. If you haven't signed in, there's a paper over there you need to sign in and get you a ticket so you can be so you can win an award.
Loot.
Yeah, you can get swag. Let's see. And I noticed yesterday Java 6 came out. Anybody using it yet? We're still on 4 something, right?
That would be a great presentation, somebody.
J2ME only works on 1.4, or it's technically 1.4.
Java 6 would be a good presentation.
Yeah. Hey, there you go.
You nodded your head. You're doing it.
Is that how you ended up?
Well, and I want to thank Tech Systems. They paid for the room, bought the pizza, brought us a nifty book to give away. Is anyone from Tech Systems here tonight at all? Okay, so I printed off their webpage here. Because last time with cyber, I really wasn't up on what they do. Apparently they're a staffing company, contracting firm, right? Okay. And I'm trying to find the one line that meant so much to me. Our industry expertise and heritage in serving thousands of clients over 20 years means we know how to deliver what you need when you need it. With over 90 locations throughout the U.S., Canada, and Europe, the Tech Systems advantage is rarely far away. Thank you, Tech Systems. Tonight is Eric Beach, trader, moving to Tulsa. And, you went ahead and did you actually come back from Tulsa to do this?
I leave tomorrow. I actually did move my start date back a week, partially because I wanted to move and I had the Jug thing to do. So appreciate it. Yeah. All right, so Eric Beach. Hey, let's see. How many of you guys have cell phones? All right. Have you ever played a game on your cell phone? That game was probably written in Java. Probably 95% of cell phone games are written in Java, and those Java games are all written in J2ME. Now there's different different phone manufacturers have their own implementations, like Nokia and some Samsung phones use the Symbian OS, which runs on Java, and it's got a different API that you can utilize. But if you've got a phone that runs Java, you can write a J2ME app, and it'll work pretty much for sure on your phone, which is nice. It kind of fits in with Java's write once, run anywhere. Deployment's a little bit different, as we'll see from a standard J2SE app, but it's really not that hard, especially since there's some nice tools that make it a lot easier for you. So as you can see, picture of a phone. Phones are not exclusive. J2 ME is not exclusive to phones, but it's mostly what runs J2ME. It's also for embedded devices, but usually those embedded devices have a little bit more of a premium on processor and batteries, so you won't find a lot of embedded devices running Java. So go through some differences between J2SE, at least some superficial differences between J2SE and J2ME. J2SE, it's written to run on full-size computers, desktops, workstations, almost unlimited memory. Not truly unlimited, but we're talking about gigabytes of memory on a phone. The minimum implementation of the CIDP, which you'll see later, it requires at least 128K, but you'll see phones with a heap of maybe 800K, as what I saw on my kind of low-end Motorola phone when I checked it out. Processors on a desktop PC are orders of magnitude faster than what you'll see on a cell phone. Also, the display, 1024 by 768 is the bare minimum you'll see on any regular desktop. And these phones, 320 by 240 by 320 is a high resolution for a phone. So, any questions so far? So far, so good. First, I want to talk about the low level. It's called the CLDC, the Connected Limited Device Configuration. This is going to be your really base level Java packages like java.lang, java.util, java.io. I got java.lang twice. Well, this relied. Should have proofed that a little bit better. But it handles, it's got your integer, string, basic I/O stuff. There's 1.0 and 1.1. 1.1 added floating point types, like uppercase float was not in CLDC 1.0. They added that. They added weak references, which are, if you've had any experience with weak references, I haven't had much, but I can at least give you the glossary definition. They're a kind of pointer that you can hold, or a reference that you can hold that won't prevent something from being garbage collected. So that helped a lot with the small memory of a J2ME device. This was kind of hard to find because when you get the jars that actually contain these lang files, or that actually contain the API, because when you download the toolkit from Sun, it's just a lang directory with a bunch of jars, and they don't mean anything. So I kind of deciphered it there. And on Sun's website, sometimes it's called CLDC, sometimes it's called JSR30 or JSR139, and there's a link at the end that gives you the APIs for all these. On top of the CLDC is the MIDP, which is the mobile device profile, mobile information device profile. This has got a lot of the more meaty, high-level stuff that helps you deal with the screen, stuff that helps you deal with the input and output from the keypad. I have a few of the packages here, java.io, java.lang. It's different lang stuff, different util stuff. It's got the LCD UI, which has got a lot of the screen elements. javax.microedition.midlet is what all mobile applications have to extend, which we'll talk about in a second. See, there's been 2 versions of this as well. 2.0 added quite a bit of changes as far as games. There's a new kind of canvas that's made to kind of supplement your writing. They're controlled and run by the application management software, which is actually software running on the phone that handles pulling up applications, terminating applications. It handles interrupting an application if, for instance, your phone rings or your phone alarm goes off, and it will call methods on your midlet to kind of notify it that it needs to clean itself up when a state has to change. Here's the 3 lifecycle methods that you've got to implement when you create a midlet: start app, pause app, and destroy app. I've got a kind of basic midlet that where I implemented a tic-tac-toe game, and I'm just going to show you the midlet that I used. Okay, here we go. I'm using Eclipse Me. I'll talk about that in a second. It's a plugin for Eclipse that makes calls to Sun's wireless toolkit, which is They call it the WTK. It makes it a lot easier to package your midlets, and it also allows you to debug while you're running through the emulator, and I can show you that in a second too. All right, so I'm extending midlet, and I'm going to gloss over everything except the 3 methods that I have to implement. I've got destroy app here. You notice that it doesn't do anything. This is when the application management software tells the midlet that it's going to be destroyed. And normally here, if you have any blocks on any sort of I/O or the device like the Bluetooth or the internet connection, you would have to release those. But since this app is really simple, it just calls notify destroyed, which lets the application management software know that we're ready to be destroyed. Now, if you're not ready to be destroyed, you can throw what's called a midlet state change exception. It's not guaranteed to stop the phone or the application management software from killing your midlet, but it's at least the only chance that you have. If, for instance, you fail when you're trying to release something and you want to do a little bit more cleanup, it seems like, from what I read, that the application management software most of the time will ignore that, because it's up to the phone manufacturer to implement to catch that exception and handle it gracefully, but usually they don't. Let's see, pause app. This is the phone notifying the application manager software notifying the midlet that it's no longer going to be the foreground application, that it's switching to something else. For instance, the phone rings and you've got to answer it, or the battery's low and it pops up a warning message. This app is pretty simple. It doesn't hold on to anything, so I can just call notify pause, which tells the application management software, fine, you can pause me. Start app is what's called by the application management software after the midlet is created. Also, by the way, I've got a slide for it, but the only way you can construct a midlet is with the application management software. You can't construct a midlet inside of any of your code. It will throw out a security exception. So only the application management software can call the creator can construct a midlet. Hey, go for it.
Quick question about the pausing. Number one, I guess, how do you know when you're unpaused, when you can start doing stuff again?
The phone will call start app again.
Oh, okay. So start app needs to be able to know whether it's already been started.
There's basically 3 states for midlet. There's started, paused, and destroyed. Destroyed is before it's created, and after the phone call, after you call notify destroyed. When the phone or the application manager software constructs your midlet, it starts in a pause state and then it calls start midlet, or start app, and then you're started. And it calls pause app, and when you tab back in, it'll call start app again. And that's basically it as far as the minimum. And this applet is pretty simple because I do all my complex logic in the canvas, which I will talk about later. Back to this.
Canvas some kind of, what is it?
I will talk about it in a second, all in due time.
Pause that.
Okay. I already talked about the midlet life cycle. From start, you can be paused or you can be destroyed. From pause, you could be started or destroyed, and from destroyed, you're gone. You have to be reconstructed again. You don't have any sort of recourse when your midlet is destroyed. Displayable. A midlet, as you can see in my example, I'll swing back over to this. In my start app method, I get the display of the phone. I get the display of the device. I call on a static method on the display class, and then I call display.setCurrent with this canvas. And really, all I want to talk about right now is the display. And setCurrent takes a displayable, and we'll talk about displayable stuff now. Basically, there's 5 things that by default implement the display. Actually, extend displayable. It's an abstract class. You've got 4 high-level items. There's an alert, which is kind of like a pop-up. It's made to be a limited amount of time. It'll basically pop up with an informational message. I actually use it in the Tic-Tac-Toe app, so I'll show you how the alert works. Alerts do have some some parameters. You can give it a timeline. It'll 10 seconds. It'll pop up for 10 seconds and then go away. You can actually make it stay. You can give it I think it's called unlimited, where it'll stay up forever, and it becomes kind of like a Windows dialog box where you just have to hit OK to get rid of it. Also displayable is a form, which is, I wouldn't say it's like a web page, but it's very similar. You can add different items. An item is another abstract class. You can add to this form and kind of construct a page with you can construct a form like a web form with multiple fields you got to enter and multiple lists. You've got a list type, which allows user selection of multiple choices. This is going to be kind of like a drop-down box where you can select one item, or it could be a list where you can select multiple items, or it'll be a radio box where you can only select one, but you can still see them all. You've also got a text box, which is it's a pop-up, and you can enter a string, and then it goes away. So it's not a permanent member of a form. It's just a pop-up, takes some data, and then goes away. And low level, which I'll talk about in just a second, is the canvas, which is really it's got methods for dealing with strings and lines and arcs and colors, where you can directly manipulate pixels on the screen. A little bit more about displayable is an abstract class. So there's 4 attributes that all displayable have because of this abstract class. There's a title, which is going to be the name that shows up in the title box. I'll show you on the emulator. It's just the name of whatever you're displaying. There's a ticker, which is kind of like a stock ticker. It sits on the screen and just continually scrolls a line of text. I don't have any example of that, but I can show you. There's some built-in examples which are really nice that come with a wireless toolkit. Commands, which are on all your phones. You've got soft keys. You'll either have 1 or 2 on the right side that usually map to different functions based on what app you're in at the time, and that's what these commands are. Your application management software will build the soft menus based on what commands you have attached to a displayable. And the command listener, you set on the displayable, and then whenever a command is invoked, it passes control to the command listener. So I think next we're going to talk about Canvas. The Canvas is a screen element displayable that uses the graphics class to do low-level drawing. It also, it's with the newer mobile device profile 2.0, they've really ramped up Canvas. They made an implementation called Game Canvas, which has got a lot more methods. It's got a lot more functionality to make it kind of like the controller for your application. And I didn't use Game Canvas in the tic-tac-toe example because it didn't really have real-time updates. It was waiting for input the whole time with a static screen. But I used it basically as the controller for my application. The paint method is what actually is called by the application manager software automatically whenever it wants, basically. Whenever a key's pressed, you can call repaint and it'll actually paint the screen. I'll show you that in a second. There's also something called full screen mode, which the canvas can take up the entire phone screen if the application manager software lets it. Some phones have it implemented where they always have battery information and signal information, and you can't not show those. I only did testing on the Nokia and in the emulator that Sun provides, but the full screen mode did actually take up the entire screen, but your mileage may vary. And whenever you go into full screen mode, the width and height of your canvas that you're available to draw on will change, so you kind of have to account for that. I had a lot of trouble getting my circles and X's to look correct with the different sizes. You got one more about Canvas? No. I'm going to show you the tic-tac-toe canvas that I used. It's pretty complex, which I didn't think it would be for a tic-tac-toe application, but I guess we all learned stuff. Okay, here's my canvas. I extended the canvas abstract class. I actually passed the midlet in the constructor of my canvas because I wanted to be able to invoke alerts on the midlet. The canvas can't change, can't make a different element, the foreground on the midlet, because the midlet can only have one displayable at a time, and that would be the canvas. And the canvas can't change that without having the midlet. Basically, I have a tic-tac-toe game implementation, and so the canvas will get a hold of that, call reset to make sure the game's back to normal. I've got a game over. Here's where I'm adding my commands. The application manager software will build however it wants based on the priority. I noticed that the Nokia application manager software actually added a different command that I didn't add, but the Sun implementation didn't do this. Nokia's added one called cancel, I believe, which acts like an exit, but I didn't have to implement it, which I thought was really weird. But Sun's emulator just has the commands that I told it to have. And then I also implement the command listener interface because I want to be able to handle my own commands. But I could have set that to some other implementer of the command listener interface. All right, I'm going to take you to the paint method, which is all you really have to implement if you extend the canvas class. I have a switch called full screen mode, which lets me go in between full screen and not full screen, just to kind of show as an example. Normally, you'd probably stay in one screen mode or another, but it definitely helped me solve different problems when I was changing the resolutions, because I noticed that the emulator that Sun created has really small title bar and really small battery and status indicators, but the Nokia title bar is gigantic. It takes up maybe a third of the screen. So my graphics had to change quite a bit. Also, part of the displayable is get width and get height. I think that's displayable. Yeah. That's just the width and height that are available for this displayable to use on the screen. It's basically what I use to. Do you have a question?
You have a laser pointer to your left.
I got a mouse right here.
That's fine.
I'm just kidding. One thing that I thought was kind of weird was that whenever you switch from your midlet and set the displayable to the canvas, it doesn't actually clear the screen. So the first thing that I do in my paint method is clear the screen. And the graphics class is what actually does the drawing on the screen. It's very similar to the graphics class that's in regular J2SE, except it's a little bit more limited. So clear screen is pretty simple. It just sets color to white and then fills the entire rectangle, the whole screen that we can write to. To show you a little bit more of the, don't have a whole lot of screen to play with. So after I clear the screen, this happens every time the state changes, the paint method's called. So I draw the grid for tic-tac-toe. I draw the game board, which uses which actually checks out the game that we're playing and fills in the X's and O's based on that. And then handle win condition. This also looks at the game status and will throw up an alert. Actually, that's kind of interesting to show you. This is all just application stuff, but I call a method on my midlet called throw alert with alert text based on who won. Either X player wins, O player wins, or it's a draw. And I have a default to error just in case I've got a condition that I didn't catch. I haven't actually seen that one yet, so maybe I coded this already. Throw alert, I'm back on my midlet, and basically it creates a new alert, which you know is that pop-up that's got a limited lifetime, and then it sets the display, right? It gets its own display and then sets it to this alert. As soon as the alert, I didn't know this until I played around with it, but as soon as the alert dies, the display goes back to the canvas. So I originally thought that I had to actually set the canvas as I had to get it back, but it's automatically set when as far as when an alert goes away. I don't know how it works with other displayables, but that's how it works with Hertz. I'm actually going to show you an example in a second. I'm going to go through the rest of my talk. Okay, record stores. These are for persistent storage across multiple invocations of a midlet. For instance, if you wanted to keep track of stats of X player versus O player, who won more, you'd use a record store. Now, this is implemented by the application management software, and all that's guaranteed is that there is a spot for your midlet. The size of that spot's not guaranteed. The contract is to try to maintain it across, taking the battery out, shutting the phone off, turning the phone back on, but there's no guarantees, which means that it's possible you could lose the settings for your game if you use them in a record store. But I guess the way that J2ME works is kind of plays it by however the application management software wants to play it, because they're the ones who are actually implementing all this stuff. Midlets cannot share record stores outside of their midlet suite. Midlet suite will all be contained in one jar, and I'll talk about that stuff with packaging towards the end. Creating midlets. Normally when you create a Java application, you code it, you design it first, then you code it, then you test it, and you compile, run it. There's a few extra steps that you have to do with a midlet. You have to do something called pre-verification. After you've compiled all the classes for your midlet, you run them through a pre-verifier, which comes with Sun's wireless toolkit, and it normally a JVM will run the classes through a class verifier to make sure that they're correctly built. But J2ME doesn't really have that luxury at runtime to examine every class because of time and processor constraints. So you run your code through a pre-verifier, which makes sure that the class files are okay and actually modifies them. I don't know what it does to the bytecode, but it lets the J2ME JVM know that they're already verified. Then there's a particular way you have to package your you have to package your midlet application. It's a jar archive, and normally manifests aren't required in a jar, but they are for J2ME. And I'm going to show you the manifest, at least the required elements. It's pretty simple. If you've seen a manifest, you've probably seen these.